Auroras occur on other planets too. All that's required to make an aurora is an atmosphere and a magnetic field. Auroras have been seen in the atmospheres of all the gas giant planets, which is not surprising since these planets all have robust magnetic fields, said Jeff Register, an instructor of physics and astronomy at High Point University in North Carolina. More surprisingly, auroras have also been discovered on both Venus and Mars, both of which have very weak magnetic fields. Indeed, scientists have cataloged 3 different types of Martian auroras. One occurs only on the planet's dayside. Another is a widespread nighttime feature fueled by strong solar storms, and another is a much patchier nightside phenomenon. The Hope Mars Orbiter, the United Arab Emirates' first ever interplanetary mission, managed to capture the discrete nocturnal aurora shortly after arriving at the red planet in early 2021. The probe's observations could help scientists better understand this mysterious phenomenon. Jupiter's magnetic field is 20,000 times stronger than that of Earth, so the giant planet's auroras are far brighter than the ones that blaze in our skies. And Jupiter's lights aren't just driven by the solar wind. Most of the particles that cause the planet's auroras are blasted into space by its close-orbiting moon Io, the most volcanic body in the solar system. Astronomers have even caught glimpses of apparent auroral activity in other solar systems. For example, 2 October 2021 studies reported the detection of radio waves emitted by multiple red dwarfs, stars smaller and dimmer than our Sun. These radio waves are likely associated with a sort of backward aurora, one that flares up near stars and is driven by particles released by close-orbiting planets, researchers said. Our model for this radio emission from our stars is a scaled-up version of Jupiter and Io, with a planet enveloped in the magnetic field of a star, feeding material into vast currents that similarly power bright aurorae. Joseph Callingham, a radio astronomer at Leiden University in the Netherlands, and the Dutch National Observatory ASTRON and co-author on both new studies, said in a statement, "It's a spectacle that has attracted our attention from light years away. Auroras are expected to be relatively common in the skies of exoplanets as well. But we'll have to get better looks at these faraway worlds to see their light shows directly." WHEREANDWHEN to see the Northern Lights. Seeing the northern lights with your own eyes is a bucket list item for astronomy lovers and travelers alike. Fortunately, they occur frequently. The northern lights are happening 24 hours a day, 7 days a week, 365 days a year, said photographer Chad Blakely, owner of the Northern Lights tour company Lights Over Lapland. But that doesn't mean they're easy to spot. You need to be at the right place at the right time. The best place to see the northern lights is any destination in the auroral zone, the area within an approximately 1,550-mile, 2,500 kilometers, radius of the North Pole, according to the Tromsø Geophysical Observatory in Norway. That's where the aurora most frequently occurs, though the phenomenon can creep farther south during particularly strong solar storms. The best time of year to see the northern lights is between September and April, when the sky gets dark enough to see the aurora. Far northern locales experience the midnight sun or 24 hours of daylight in the summer. Most action usually happens between 9 p.m. and 3 a.m., according to the Geophysical Institute of the University of Alaska Fairbanks. Keep the moon phases in mind, as a bright full moon might fill the night sky with light. Check local weather forecasts as well, because you won't be able to spot the aurora through the clouds. In conclusion, the aurora is one of the most stunning natural phenomena on our planet, and its beauty has captivated humans for centuries. But there is still so much we don't know about this incredible light show, and scientists are working hard to unlock its secrets. By studying the aurora, we can gain a deeper understanding of the Earth's magnetic field and the impact of the solar wind on our planet. So, don't miss out on this amazing opportunity to witness nature's breathtaking light show. Don't forget to subscribe to our channel, or you will miss out on the most stunning and awe-inspiring natural phenomena on Earth. Join us as we take a journey into the heart of the polar regions and explore the dazzling display of colors known as the aurora. From the bright and vivid hues of the northern lights to the ethereal beauty of the southern lights, this video will take you on a breathtaking adventure through nature's very own light show. Don't miss out on this incredible opportunity to witness the magic of the aurora for yourself. Watch the mesmerizing beauty of the aurora. What is Aurora Borealis? The term Aurora Borealis was first used in 1619 by the Italian astronomer Galileo Galilei, who named it after the Roman goddess of dawn, Aurora, and the Greek god of the north wind, Boreas. The northern lights, also known as the Aurora Borealis, are an ethereal display of vibrant lights in the sky that has long captivated humanity. Beautiful images of this natural occurrence are currently getting viral. But what exactly causes this eye-catching display? In this explainer, we will look at the science behind the northern lights and discuss everything you need to know. Decoding the name. The term Aurora Borealis was first used in 1619 by the Italian astronomer Galileo Galilei, who named it after the Roman goddess of dawn, Aurora, and the Greek god of the north wind, Boreas. According to a report from NASA, the first auroral citation is from China, dating to 2600 BC. Fu Pao, the mother of the Yellow Empire, Xuanyuan, saw strong lightning moving around the star Su, which belongs to the constellation of Baidu, and the light illuminated the whole area. While the earliest depiction of an aurora is thought to be from way back in 30,000 BC in Cro-Magnon cave paintings in modern-day France. Myths associated with Aurora Borealis. The enigmatic Aurora Borealis has captivated people since ancient times. According to a well-known Finnish folktale, the Aurora Borealis is caused by a magical firefox that runs through the snow and shoots sparkles into the sky with its tail. The Sami people of northern Scandinavia believed that discussing the northern lights was inappropriate because they were thought to be the dancing spirits of the dead. The northern lights were thought to be reflections of the Valkyries, female fighters who determined who survived and perished in combat armor as they guided the soldiers to Odin in Norse mythology. So, what exactly causes Aurora Borealis? Researchers are still working to solve the mystery behind the fascinating lights. Even Galileo, who named them, had the misconception that the auroras he saw were caused by sunlight reflecting from the atmosphere. According to the most widely accepted theory, the Aurora Borealis, or northern lights, are the result of electrically charged solar particles interacting with particles in the Earth's atmosphere. The sun continuously produces a solar wind of charged particles, which exits the solar system. The magnetic field directs these charged particles to the Earth's polar regions, where they collide with atmospheric molecules such as oxygen and nitrogen, generating light. The colors of the aurora are affected by the types of gas particles in the Earth's atmosphere with which the solar wind particles collide. Nitrogen